This week we are going to start integration. Now, in the previous discussion, we actually learned about the differentiation, and so we learned about the basic rules of differentiation, and we also learned about the application of differentiation in our real world. And from week 9 to week 12, we are going to learn the integrations. Okay, so our objective will be, right, for the first lecture on integration, we are going to learn about the notation of integration and also the meaning of integration, right? The definition of integration and the notation of integration. Now, after that, in this discussion also, we are going to learn about the basic rules for integrations and find the particular solution for differential equation. Okay, so let's start with the antiderivative. Now, what is an integration? Right, the integration is actually the inverse function of differentiation. So, for example, here we know that if we have x to the power of 3, right, and after differentiation, right, we get 3x squared. We call this derivative. Okay, differentiation is the process, and what we get here is called the derivative. Okay, so please take note that the derivative refer to the answer we get. The differentiation is the process. Now, then this derivative, right, if we go through the process of integration, which is the inverse of differentiation, we will get the antiderivative. All right, so the antiderivative refer to the answer for the integration. Now, the word anti here means that it's the reverse. All right, the reverse of derivative. Okay, so right, the first thing we need to know is that the integration is actually the inverse of differentiation. All right, so if we differentiate x to the power of 3, we get 3x squared. Therefore, the integration, when we integrate 3x squared, we will get back x to the power of 3 plus c. A c is a constant. Now, I'm going to explain the c later, all right? What is c and why do we need to add a c? I'm going to explain later. Now, however, right, the first thing, right, about the definition of antiderivative will be, now if a function is antiderivative of another function, all right, so therefore, all right, f prime is fx, all right, for all the interval. Okay, so if the f is the antiderivative, it means that we get the f by integration, all right, of f. Therefore, differentiate f, we'll get back the small letter f. Okay. Now, why do we have to add back the constant c? So let's take a look on this example. All right, we have three examples here. Now, when we have the first function, x to the power of 3, after differentiation, what do we get? We get x, 3x squared, right? Okay, now for the second function here, f2, after differentiation. Okay, so please bear in mind that we are talking about differentiation. So after differentiation, what do we get now? We have 3x squared here. Now, when we differentiate 5, we get 0, right? So it will have plus 0. Okay, plus 0. But however, we are not going to write the 0 here. Okay, now consider function number 3. When we differentiate 3 x to the power of 3, we have 3x squared again, and we differentiate 97, we get 0. Okay, so from here it means that when we differentiate these three functions, we get the same derivative. We get 3x squared, right? We get 3x squared for both. Now, what happened to the constant here? The constant, after we differentiate, we get 0. Therefore, right, for this 3, we are going to add plus 0. Now, as we know that the integration, right, is the inverse of this. So when we integrate 3x squared dx, when we integrate this 3x squared, we will get x to the power of 3 plus a number behind, right? There should be a number behind as the constant. Now, however, from here, we do not know what is the number. We don't know whether it's 97 or -5 or 0 or some other numbers. Therefore, right, we are going to put a C to indicate that there will be a constant behind here, but we do not know what is the number about. Okay, we don't know what is the number. Therefore, the C actually means that it's a constant, right? So in this case, when we integrate any function, we will have plus C at the back to show that there will be a constant, a number where we do not know, right, at the time of integration. Now, next we are going to discuss the notation for antiderivative. Notation means that the symbol we use. Okay, in maths we have a lot of symbol. All right, so the symbols we use for antiderivative is called the notation. Okay, so basically for integration, right, we are going to use this symbol. Okay, when we integrate, we use this symbol. This is the symbol for integration. Okay, so we have this symbol for integration. And the fx, right, is called the integral. Right, so we integrate the function fx. And dx here refer to the variable of integration. So we integrate fx, right, with respect to x, means that we are actually integrate all the variable x. Okay, so after we get the answer, all right, the answer is called antiderivative, and the constant, right, we put a C, refer to the constant of integration. Okay, so now we call this indefinite integral, right, when we just integrate the function, right? We are going to learn definite integral later when we have the integration involve numbers. Okay, so now after we know the symbol we use for integration, now we are going to learn the basic rules for integration. Okay, so now there are two concepts we need to know, right? The first, right, the integration is the inverse function of differentiation. Okay, so in this case, right, when we have a differentiation here, followed by the integration, so we have, right, in this case, now let's say we have f, function f, after differentiation, we get f prime. Therefore, the f prime, after integration, we will get back function f. Now, in this case, we say when we integrate the derivative, integrate, that's one, the derivative, on x, we will get back fx. Of course, we have to plus a constant. Okay, so when we integrate the derivative, we will get the antiderivative, right, and a constant. Okay, so this means that when we put two functions together, whether it's the differentiation first followed by the integration, or the integration first followed by the differentiation, right, we will get back the same answer. Okay, so this is the answer. All right, the original function here. Okay, so integration is the inverse of differentiation. At the same time, differentiation is the inverse of integration. So this is the basic concept that we need to know. Now, when we integrate the function, right, these are the basic integration rules. Okay, so first, if we differentiate a constant, a number, we get 0. Okay, so then integrate 0 or integrate nothing, right, will give us a constant. Okay, so now if we differentiate kx, we get k, right? It means that when we differentiate the x, we get 1. 1 times k, we get k. Therefore, integrate a number will give us kx. Okay, for example, if we differentiate 2x, we get 2. And in this case, integrate 2 will give us 2x plus a constant. Okay, so now if we differentiate k, multiply a function, so we differentiate the function only, the k remains. So in this case, all right, if we integrate k fx, so we are going to put the k aside, we only integrate the function, just like we only differentiate the function here. Okay, we differentiate the function only, so when we integrate, we also integrate the function. Next, now when we differentiate the addition or subtraction of two functions, we differentiate them separately. Okay, we differentiate one by one. We differentiate fx first, then followed by gx. So we plus or we minus. Now the same thing goes to integration. So when we integrate the sum or subtract of two functions, we also integrate them separately. We integrate f first, then plus or minus, followed by the integration of g. Okay, now next one. Okay, when we differentiate x to the power of n, right, the n, right, we multiply the power, and the power reduced by 1. Okay, so when come to integration, we are going to do the reverse. First, all right, the power reduced by 1 here, we are going to add back the power. So we plus, we take the power plus 1, and after that we divide. Since this is my multiply, we divide by the new power. Okay, for example, let's say we differentiate, okay, x 1 over 6 x to the power of 6. So what we do is we bring down the power, we bring down to multiply. So we have 6 multiply 6 plus 1, 5. And we get x to the power of 5. Now, if we integrate x to the power of 5, so what do we do? First, we are going to add back the power 5 plus 1. So we add the power first, then divided by the new power, which is 6, right, plus c. So then you can see here we have x to the power of 6 over 6, which is this one, x to the power of 6 over 6. Okay, so remember we will add the power first, then only we divide. Okay, so continue from here. If we differentiate the sign, we get cos. So we integrate the cos, we get the sign. Okay, differentiate cos, we get negative sign. And integrate sine, we get negative cos. Okay, so differentiate tangent is secant square. So integrate secant square is tangent x. And differentiate secant, we get secant x tangent x. Therefore, integrate secant x tangent x, we get back secant. And differentiate cotangent x, we get negative cosecant square x. integrate cosecant square x, we get that negative cotangent x. So since this is negative, all right, so when we integrate something without negative, it will be a negative for the antiderivative. All right, so when we differentiate cosecant x, we get negative cosecant x cotangent x. So when we integrate cosecant x cotangent x, we get negative cosecant x plus c. Now, all right, the idea here is, all right, we need to relate the integration with the differentiation. Okay, so all these so-called integration rules, we need to remember it has a formula. So we need to remember this has a formula. Now, at the time being, we never discuss how the integration of cos will get integration of cos x will get sine x. Now, we never discuss how from cos x after integration becomes sine x. Now, however, we are going to remember it has the formula first. Now, if you are interested in why integration of cos is sine, or why differentiate sine we get cos, you can further your study on YouTube, right? You get some relevant information. But for our course, we just need to remember the formula only. Okay, so let's take a look on some examples. Okay, first, describe the antiderivative of 3x. So antiderivative of 3x means that we need to integrate 3x. So when we integrate 3x, first, right, we are going to integrate the x only. Right, 3 is the coefficient, we just put aside. Now after that, right, for the x, the power is actually 1. So we are going to plus 1, right, add 1 to the power. And after we add 1 to the power, so we are going to, right, we have 2 here, so we are going to divide, right, the whole function with the new value of the power, so which is 2. Right, so 1 plus 1 is 2, so divided by 2. So here you can see we have x squared over 2, right, plus c. Now after we integrate, we need to actually plus this constant behind. Okay, so simplified, we get this. So this is the antiderivative of 3x squared. Okay, so now in example 2, right, so these are the general steps we use for integration. Right, so first we have the original integral, right, like this, original integral. So we rewrite first, okay, so we rewrite as, right, 3 integration of x to the power of 1. Now after that we integrate, so when we integrate, when we use the power rule, we plus 1 to the power and divide by the new power. So after that we simplify. Okay, so these are the general steps for integration. Okay, in the next discussion, right, we are going to discuss the initial conditions and particular solutions. So initial condition here means that we are given a point so that we can find the constant, the c. Okay, so now find the general solutions of f prime x equals to 1 over x squared, where the x is more than 0. And find the particular solutions that satisfy the initial condition f1 equals to 0. Okay, so what we are going to do here is, first we are going to integrate this. Okay, so we are going to integrate this, and after that we are going to use this in so-called initial condition here to find the constant. So to integrate this one, right, 1 over x squared, and we know after we integrate we will get fx, since this is f prime x. So when we integrate f prime, we get back fx because they are the reverse of each other. Okay, so change this one to power. So we will have x to the power of negative 2. So when we integrate power plus 1, so power plus 1 we have negative 1. Okay, negative 2 plus 1 we get negative 1, and divided by negative 1 plus the constant. Okay, so we have x to the power of negative 1 over negative 1 plus the c. Okay, so this is what we have for the fx. Now, however, we do not know what is the constant c here. So we are going to use this information to find the c. We call this information initial condition. Okay, according to the initial condition, we know that this should be the x, right? Okay, x, right, refer to 1. 1 is the x. And the answer we get here, the fx is the y. So the y is 0. Okay, the x is 1, the y is 0. So substitute into the function when the x is 1, alright, the y is 0. So we substitute 1 into the x is 1, the y is 0. So from here, solve this equation, we will have the c is 1. And now, right, we have a particular solution. Right, the particular solution for this is, right, negative 1 over x plus 1, where the x should be more than 0, as given by the question itself. Yeah. Okay, now we know that as for negative 1 over x plus c, right, it can be many solutions. Right, if the c is 4, so we have this line. If the c is 3, we have this line. If c is 2, we have this curve, right, and so on. Now, however, with the initial condition f1 equals to 0, we are able to find the particular solution. Right, the particular solution here, it means that we are going to find the solution that satisfies this f1 equals to 0. Okay, so when x is 1, the y is 0, so we have this point, we are able to find the line that satisfies this condition.